Continuing with our study of motion, let's take a look at kinematic equations. To review, let's take a look at what we've done. We're studying mechanics, which is the study of motion, and we've looked at motion using language and diagrams and graphs, and now it's time to explore the algebraic expressions of motion, and that's what the kinematic equations are that I'm going to show you. We're still describing motion in terms of displacement and velocity and acceleration. And so in this video, I'm going to show you the first kinematic equation, and then in subsequent videos show you some more equations. All right, so let's get right to it. For our first equation, it's actually quite simple. Equation number one simply says acceleration is change in velocity over change in time. And many of us recognize this simply for what it is. As we looked at the motion of objects graphically, we recognize this formula quite simply as a slope formula, because acceleration, if we look at a velocity time graph, we know that the slope of a velocity time graph is represented by acceleration. Let me just use the acceleration symbol there. So the slope of a velocity time graph is acceleration. And so if we want to abbreviate this wordy equation here, we could simply say that acceleration is the change in velocity over time. Or maybe more simply, acceleration is simply delta V over delta T. And I hope you guys are copying this down in your composition book. All right, and I guess as a review, my handwriting's not too perfect there, but this triangle, the delta symbol means change. All right, so there we go. There's equation number one. While we're at it, this hasn't taken much time. Let's take a look at equation number two, because it is simply just a rearrangement of the first equation. So just to go back and look, we said that in equation number one was acceleration was a change in velocity over a change in time. And all we're going to do here is just expand that a little bit. So let's see if we know what this means then. All right, we know that change in velocity is by taking y2, which is your final velocity. This is an f and that's a v. Final velocity minus the initial velocity is the change in velocity. And some of you remember this from work we've been doing recently. So another way to express equation number one is to say that acceleration is equal to the final velocity minus the initial velocity divided by the change in time. All right, so now let's clean this up a little bit. What if we multiply both sides by time? Then this equation will turn into acceleration times change in time will give us the final velocity minus the initial velocity of some object in motion. And then if we add initial velocity to both sides of the equation, then we get acceleration. And I'm just going to move it to acceleration times time plus the initial velocity equals the final velocity. And so now all I'm going to do is take this equation and I'm just going to clean it up and rearrange it. Order of operations says that we can add and subtract. It doesn't matter the order we do this in. So I'm going to do it this way. I'm going to say that the final velocity of some object is equal to the initial velocity of the object plus the acceleration of the object times time. And so there you go, folks. It doesn't get much simpler than that. Here is equation number two. Final velocity is equal to the initial velocity of an object plus acceleration times time. And you may notice I'm not working any sample problems for you at this point. I just want to get these equations to you and have you see more or less intuitively where they come from. So the first equation simply describes the slope of a line, and equation number 2, all we've done is just rearrange the equation to solve for a variable of our choice. And so I'll stop this video at this point, and in the follow-up videos we'll look at equations 3, 4, and 5.